Hey everybody, in this video we're going to be creating this awesome melting effect with geometry nodes along with a great dynamic material to really sell the effect. If you guys really like this, there's a slightly more improved version available on my Gumroad, link in the description. It has a few more bells and whistles and is a little bit more efficient, plus it comes with a few extra dynamic materials like the one that we make in this video. So I'm going to hop into my scene here, switch over to cycles, GPU compute, 128 render samples, and color management, let's set this to high contrast. So I'm going to start by deleting the default cube, Shift A and add in a cylinder, tab into edit mode, and scale on every axis except the Z. Tab back out, and let's grab our camera here. Take these, set all these values to 0, rotation, set this to 90, and set this to 0. Then drag it along the y-axis. I'm also going to adjust my sensor size to 1500 by 2000. Now we can actually hop into geometry nodes, click on our cylinder, and create a new effect. Now the great part about this is that this effect will work on any mesh. So for this, I'm just using a cylinder to create sort of like a candle, but you can apply this to literally anything. So we'll come down here, Shift A, and add a mesh boolean. Plug that in there, and then let's bring in an icosphere. I'll set my subdivisions to something high, like 4, and plug that into the mesh too. Now, in order to make this much more controllable, I'm going to add in an empty in my scene. Create an empty sphere, and there we go. If we click back onto our cylinder and add in an object info node, switch this to relative, and plug the input into our group input, we can select our empty. Now, if we add in a transform node and just plug all of these values into their corresponding sockets, you'll see we actually have the ability to cut out the part that we want to be melted. Now I'm actually going to go in and add in a delete geometry node. Then if we add in a math node and set this to less than, and plug this intersecting edges into the value, and the value here into the selection, you'll see we sort of get this cutout for the edge of our boolean. This is what's really going to give us the effect, because we're going to create our molten material sort of falling off from here. Now, we'll add in a mesh to curve, then a resample curve, set to length, and we'll set this to something quite small, like 0.01. Then Shift A, curve to mesh, and a mesh to points node. There we go. Slide this over. This is going to be a relatively big node tree, so make sure you've got plenty of space to play with. Now if we add in a points to volume node and lower our radius here by a whole lot. Crank up the density to make it clearer, and we can add in a volume to mesh node. You'll see we're sort of getting this ring. It's still way too large, so I'm going to lower this radius a heck of a lot more. In fact, you know what we can do? If we add in a math node, set this to divide, and divide by, I'm going to say like 1,000, and then grab a group input. We can plug this value in here, and this into the radius. And now we have sort of like a control over how much molten wax appears at the rim where it's supposed to be melting. We can add in a join geometry node as well, and if we mix this with our booleaned mesh, you'll see how we're sort of getting that melting effect. But now we actually need it to like slide down so it looks like it's being pulled by gravity. To do this, pull in a set position node, plug that in here, and then bring in a geometry proximity node. For our target geometry, let's grab our icosphere over here and plug that in. Now, if we grab a math node and set this to greater than, and plug our distance in here, and set our threshold to something very low. I'm going to go with 0.005, and then add in a multiply, and plug in these values here. We can add in a vector math node, multiply, switch the bottom value to 1, so that way we're only affecting the z-axis, and we can plug this into the offset. Now, that doesn't look very good, but you can see if we sort of like make this more extreme in the negative, it does actually pull it down. So now the trick is going to be making it so that it looks realistic. To do this, let's add in a noise texture and a color ramp. I'll slide these values up just a little bit so we get more contrast, and then bring in another math node. We want it to be sort of like more extreme and like more pointy in certain parts. So I'm going to switch this to power and plug this into the base here. Shift D, set this to multiply, and plug that in there. Now if we grab another group input and plug in our values here, we can actually slide this over and we'll multiply these values together. Now you can see if we adjust this exponent value and this sort of more linear value, we're starting to get that effect of like it being pulled down by gravity. So I'm going to lessen this a little bit. And I'm also going to add in a multiply node in front of both of these, just set to -1. So that way we can set these as positive values over in our interface. And there we go. Now I'm going to also adjust my scale here. Adjust the detail a touch, and set this to 4D, so that way we can get just a randomness input. I quite like those values, so I'm going to leave it with those for now, but I'm going to grab our old friend, the group input again, and just plug in all of these values so that we can control them again in the future. Now, another thing, while you're doing this, make sure to be saving your file a whole bunch because we're going to deal with a lot of voxel remeshing, and it's easy to accidentally click a value and set it weird so that it ends up crashing your computer while you're building it. Now, there is one more thing I actually want to do. I'll slide this down, and you'll see if we hide our cylinder for now and bring in a Suzanne head, and then apply our same effect to this, you'll see we're getting this really weird glitching effect. And that is because our Boolean is getting weirded out. So what we can do is we can adjust these values here and plug these into the group input as well. You'll see we're not actually getting the liquid buildup effect, and that's just because our default values are set too low in some areas. So if we add more there, increase the exponential, then if we also turn off self-intersection, that'll get rid of that weird sort of like eye effect. I'm going to lower the scale a little bit, and I'm actually going to come in here and change our voxel amount to 128. This doesn't have to be too crazy because it's not going to be the final actual remesh, and usually melting things at a small scale makes them more sort of globular. But you can see like there, we also have this issue of if we hit Alt-Z, it's melting into itself, and so we don't want that to happen. What we want to tell Blender is, okay, If it's on a face that's pointing up, don't make it melt down into the mesh. And there's a really easy way to do this. If we bring in a transfer attribute node, and we just plug our original geometry into the source, Shift A and bring in a normal node, shift this to vector, plug the normal into the attribute, add a vector math node, and switch it to normalize, and plug in this value here. Now we have the information from the nearest face, and we can tell if it's pointing upward. So if we add in a separate XYZ, plug this in, Shift A, math node, check if it is greater than, on the Z, 0.1, and then bring in a combine XYZ, and duplicate this vector math node here, plug this into the bottom, and we're getting this strange effect. Actually, I think this needs to be set to less than. There we go. So you'll notice this still doesn't look amazing. We have this weird like clipping at the top. It's not looking great. Fortunately, we can just duplicate our join geometry node here and join our distorted mesh with our original here. And you'll see, voila, we have a melting sort of effect. Now, it still just looks like you stretched out a mesh and put it into an actual blender, but this is where our friend voxel remeshing comes into play. So Shift A, add in a mesh to volume, Shift A, volume to mesh, and I'm going to actually switch this voxel from amount to size. Then add in a math node, set to divide, set the bottom value to 100, set this to something like 10, and if we plug this in here, we now have a little bit more fidelity compared to just grabbing the slider directly. I'm actually going to set this to 1,000, and you'll see it looks like super puffed up right now. That's just because of this exterior band. Just set it to 0, and there we go. Now you'll notice this really doesn't look great. It's super like bumpy. It's just all super weird. So in order to smooth this out, let's add in an edge vertices node and a vector math node. Add these two positions here. Shift D, switch this to divide, and plug this in here, and set all these values to 2. Now, if we bring in a set position, plug this in here, and plug this into the position slot, you'll see it smooths it out just a little bit. So we're going to actually have to repeat this a great deal of times. I think I'm going to repeat it like 60. So Control G to actually group these, and let's spread these out and give ourselves a lot of space. Collapse our set position node. Then if we press Control Shift D to duplicate while keeping our inputs connected, we can plug these in, highlight them both, Control Shift D, plug in the geometry from here, Control Shift D, and I'm going to make these columns of 10. Highlight all of this, including this little juncture here, and press Control Shift D, slide it over, then Shift R to repeat, and just plug these geometry outputs into the appropriate inputs. Now I'm just going to come down here and grab our last set position output and plug that into the geometry output. And as you can see, it has been smoothened out. And hop back out. And what I'm going to do is I'm going to come over here, and after this first join geometry, I'm going to add in a mesh to volume. and a volume to mesh. Now we can set the voxel size to the same thing as our mesh to volume here. One more thing we can do is if you click this drop down here and press timings, it'll show you how much time it takes to compute each node and the total time. So you'll see we're at 840 milliseconds. That's quite a lot. So what I'm going to do is I'm going to add in a switch node, plug that in there, and then just grab this join geometry output from here and plug that into the bottom. Now if we add our group input, we can add a socket for the switch. And you'll see if we switch to this mode, we're borderline real time in our melting effect. And then if we switch back, we have our nice looking effect. And I'm going to actually lower our voxel size additionally, or actually what we can do, again, duplicate the group input, and just add it into here. So now we can control it from the interface. Something like 4 looks quite good to me. Now, one more thing I want to do is I want to actually distort this edge a little bit. You can see right now it's very clearly just like sort of a cutout of a sphere. So I'm going to up our resolution a bit, and I'm going to set our switch to 1. So that way it works much more real time. Now what we can do, if we slide these out of the way, and then add a set position in for each of these, Shift A, and let's bring in a proximity node, and plug our icosphere into the target again. Now, if we add in a math node, set to subtract, and set this top value to something like 0.05, and then plug our distance into the bottom, duplicate it again, switch to greater than, plug this into here, and set this to 0, and add a multiply. And maybe multiply this by 10. You can slide these over, add in a vector math, and plug this into the top slot, switch it to multiply. Then again, we'll bring in a noise texture, add in a color ramp, slide up the blacks a little bit, and add in another vector math, and set this bottom to something like minus 0.3. So it's not quite as intense. Then we can plug this in here, and plug this into the offset. Now you'll see it looks just super weird. Add in a vector math node, and multiply it by like 0.01 on the Z. Then plug this into the offset here. Now if we fiddle with our noise here, maybe we can make this a little more intense. Maybe set this to -1. There we go. Now add in just one more set position and plug this in here. And you can see now it sort of melts and gives way, which is very, very nice. I like that effect. Now that we have that all set up, I'm actually going to hide Suzanne and bring up our cylinder. And you can see, okay, we'll move this a little bit so it's just a touch flatter. But if we lower our voxel size, we do have this really nice looking candle effect. I'll switch over into our sort of previs mode and maybe add a little bit more molten wax and increase our exponent and lower our sort of like linear fall off. There we go. I actually want this distortion to be a little bit more intense. So I'm going to set this to -2 here. And set our scale to closer to like 3. Switch to 4D to get a seed generator. There we go. Now if we switch back, you'll see we have a very awesome looking molten wax or molten material effect being added. Now there is one last thing I do want to change though. I'm going to switch us into previs, and you'll notice if I drag this empty down on the Z, my noise evolves quite heavily. And so I want the noise texture to sort of move with the empty. It just gives a slightly more realistic effect. And in order to do that, I'm going to take our object info, pull it down here, and plug it in. And then add in a position node. Then if we use vector math, set to subtract, and subtract this location from the position and plug this into the vector, you'll see our noise texture sort of moves with us. We also have to do this for our noise texture up here though. And so what we can do, we can just grab this value here and plug it in. I'll also plug our W slot into both of these. So now we can make it evolve with time if we like. And of course, we can always slide these and switch it into nice and pretty mode. Add in a set shade smooth at the end and a set material. Grab a group input and plug the material slot into here. Then grab a geometry proximity node, Shift D and duplicate it. And grab this join geometry down here. Now, if we once again grab our icosphere and drag it all the way over and plug it into the top here, Shift right click to create a point here, join geometry, and join this with our molten mesh. There we go. We can now plug both of these into the output as well. We're going to need both of these values in our dynamic material. So come down here and save them as distance.1 and dist.002. Shift Alt click to plug this into the output, and let's jump over into the shader. Create a new material and name it wax. Jump into rendered view and assign it over in our interface. I'm going to move our light a little bit, so that way we have a slightly more appropriate environment. Now add in an RGB and plug this into both the base color and subsurface color. I'm going to set this to something like a really deep red. And then I'll set my subsurface to something like a 0.06. Yeah, there we go. Then if we add in an attribute node, Shift D to duplicate, and type in dist.001 and dist.002, you can see we're getting these two masks for how close it is to the hot material. Shift A, add a mix RGB, set it to multiply, and plug both of these into here, set the factor to 1, and now we have a mask of where it should be sort of like more molten and where it should be less molten. I'm going to add in a color ramp, and I'll set my black to a little bit above 0. I don't want it to be quite liquidy. Slide this over here, slide this up a touch, and lower this to like a 0.5, 0.6. Control Shift click and plug this into our roughness value. I'm going to slide up my specularity and specular tint, but you will see now that we only have a sort of wet wax when it's close to the booleaned edge, which we can assume is near our heat source, and where it's sort of pouring down the sides. And that is it for this tutorial. Thank you guys so much for watching. If you enjoyed it, please give it a like and a subscribe, and thank you for watching.